Hey, I'd like to welcome you to another episode of Mission Matters. My name is Adam Torres, and if you'd like to apply to be a guest on the show, just head on over to missionmatters.com and click on Be Our Guest to apply. All right, so I have Martin Halliwell on the line, and he is president of Footprint Engineering. Martin, welcome to the show.
Thanks, Adam. Thanks for having me.
All right, Martin. So I'm excited about this interview. You have quite a few patents. We're going to talk about a couple of those. I know I've been on an email newsletter of yours for quite some time now and just kind of following the journey of what you're doing. So we'll be talking about really unique patents to reduce CO2 in the built environment. But maybe just to get us started, let's start with our signature question. So our Mission Matters Minute that we ask all our guests. So, Martin, we at Mission Matters, we amplify stories for entrepreneurs, executives, and experts. That's our mission. Martin, what mission matters to you?
My mission, my passion is to reduce CO2 in the built environment by using my experience and by applying a lot of creativity.
Yeah.
I believe I've got a story to tell after many, many years, but also the good news is that whenever you reduce CO2, you lower costs and schedule.
Yeah.
And that typically is in that concrete rebar equation, where a lot of this stuff is high footprint.
So let's go further into, and thank you for sharing that first off. And I love bringing people that are mission-based, especially entrepreneurs that are out there making a difference, and especially individuals like yourself looking at, taking their expertise and thinking about, global systemic issues like lowering CO2. So let's start off with maybe your background. So how did you get started really as an entrepreneur and on this journey?
I started in June of next year, 2022. It'll be 40 years. And I had a good fortune of working for a very good company, a company in Toronto, well-known, deep foundations contractors. And I was in the right place at the right time within 2 years when I got my PEng in 1984, professional engineering designation as a civil engineer. I was a graduate from University of Western Ontario in London, and worked for a fellow by the name of Bill Lardner. And they needed an operations manager at one point, and I got the job. After putting in many, many hours, something I would tell young people is it pays to give over and above. And in the next, I think by 1989, I had set up and run 1,000 projects.
Wow.
Working with some of the toughest dirt and innovation. They were quite an innovative company, arguably the market leader at the time in Toronto. I had 100 tradesmen that I moved around at night, and that I still remember to this day, many of them fine people. And one of my advantages, Adam, really is I did work with men, and I do respect the opinion of a tradesman. So when I look at their frustration with typical engineers, or their frustration, let's say, with not being listened to, and they always had good ideas. Tradesmen want to do things right, and they see a lot of things that are done incorrectly, and they wonder why. And if you listen to them, one trick I had is when they went home at night, I give them my worst problem, and they would come in the morning and shock me with some of their suggestions.
Wow.
Because it was really cool that they would go home at night and care that much when they weren't being paid. I mean, these were union guys, and they all did very well. Portuguese, Italians built Toronto. So in the international union, I have a lot of respect for unions. I mean, I've been exposed to non-unions, and that put me on a journey where in 89, I figured, well, I want to learn general contracting.
Yeah.
And I want to learn heavy civil contracting. So I was very operational from that point on. Did some of the toughest work, like the Welland Canal rehab, where I got exposed to concrete rehab. I did supervised commercial buildings. They were a big company called Matthews Group, another great group of people. And I think it's the mentors you meet and the people that take time, and also your ability to ask good questions. I was always a very, very curious guy. And when you put 75 hours a week in consistently for 40 years, you learn a lot of stuff. So even today, Adam, I put those kind of hours in, but mainly it's to my mission, right? It's to make a difference. I believe this experience of watching concrete and rebar wasted, and wondering, wondering about why certain things are done, and yet also in the competitive environment, being a contractor, figuring out ways that we could always win the bid because we were using less concrete and steel, or we had a better idea. What happens in foundations, geotechnical, there's a lot of unknowns. So you end up wondering, okay, what's the best system?
Yeah.
And I developed a theory that if you pick the best system, you were 3/4 of the way there. And then if you were working with engineers that were good at their detail, you were all the way there. Because there's potentially a number of scenarios that can result in a longer schedule or more cost. Why do we place more concrete and rebar in the ground than we need to? And yet you can't have any risk there. So you learn to manage risk. And today I would say I've done 4,000 geotechnical design builds in a similar area. And I had my own business there for 22 years, got shotgunned out by a rich guy. Fair enough. If I didn't do that, I wouldn't be at a farm, So I have a farm. I'm still working, but I'm learning from farmers, and I'm learning from Mennonites, and I'm learning from, still learning a lot of welders. When I did a lot with welding, and so I still do stuff with welding. I mean, I have my own welders, but not a big team, right?
Yeah.
I just do things like, for instance, some of the things I'll talk about today, I'm doing testing on. The geothermal patent I thought we might mention today. But you go ahead, Adam. I'll let you ask another question maybe.
So Martin, there will be some people that are watching this that are, first off, I mean, congrats on going on 40 years in the business and really innovating and pioneering different things, not just settling for the status quo in the industry. So first off, congrats on that. But there's going to be some people that watch this that maybe aren't quite as far along on their journey, and maybe they're just getting started out. Maybe they're still in that apprenticeship phase that you mentioned in the beginning. That's so important. Maybe possibly working for a company and learning and really having an intrapreneurial spirit. So I feel like a lot of times we talk about entrepreneurs and starting your own business, but we forget that intrapreneurial side of doing something where you're at the company you're at. Like many of the tradesmen that you mentioned, like solving problems and really being of benefit and just going that extra step. What kind of advice would you give to that next generation that's out there and they're just getting in and really into the job marketplace and they're trying to find their way?
Well, I think that it's important to get going. In other words, take something. Don't worry about your starting salary so much.
Yeah.
Don't worry about the benefits. It's in the new generation, we can call it the millennials. The other thing I would say is, use your phone for phone calls. Don't use your phone for texting. Don't use your phone to interrupt meetings, to get back to someone. The texting world has really, I think, impacted things. I mean, in the 80s, I think I was there when the first cell phone came out. And we, I still to this day will coach young people and say, phone the guy or phone the girl, because you end up in 5 or 10 minutes saving 2 days of emails. And you can get a lot done, particularly if you know how to ask questions. So ask lots of questions, put a few extra hours in. If you don't like your boss, move on. If you get somebody who takes an interest in you, like I take a lot of interest in young people. There's a lot of people I've mentored, and a lot of them are industry leaders today, because I would hang around with them and I would talk. There's a guy named Dave Miller at that first company, and we'd sit there and we smoke cigarettes, and he'd work till 6 o'clock at night. And I had to drive home an hour and a half then. Yeah. But I wanted those lessons from that guy. He was the practical guy. He was the other partner. So you get involved with equipment. If you're doing a self-performing contractor business, you get involved with equipment, heavy equipment, excavation equipment. We did a lot of stuff with custom equipment, even at that first company. So it's the extra hours, I think, and realizing that as an engineer, you might want to stay in the field a little longer. You don't have, there's not very few guys will do what I did, but eventually I got into professional management. And in 1993, keep in mind, this is only 11 years later, I was president of a mechanical electrical company. I'd gotten my MBA part-time, and I had 500 people. Wow. And they were 17 multidisciplinary groups, and I burned out of there by 94. They let me go. I didn't think my shit stunk, a little bit of ego problem there. So, but they all said I was smart, and even in that company, I paid attention to the tradesmen. I created this structure where the field supervisors would be there, and we'd have meetings, and we would try to figure out the risk for these estimators.
Yeah.
That, mechanical electrical business is technical, and the estimators tend to be tradesmen anyway.
Mm-hmm.
I integrated engineering in. I believe engineering and tradesmen together, properly meshed, are going to be the benefit of everybody, the benefit of society, and the benefit of true innovation and value engineering. Today, I do value engineering, which a lot of people understand is led by Americans with the Save International. I keep involved with all the associations. I can't say I dedicate a lot of time, but I've been to many, many trade shows. And when I go to a trade show, if you're a young guy going to a trade show, forget about the beer, get up early, go walk around those booths and introduce yourself and talk to them, right? So I have an extensive network. And the other thing I do, Adam, is I keep in touch with it. It'd be very rare that I wouldn't phone someone up out of the blue who I hadn't talked to for 5 years. So using the phone, right?
Yeah.
I get the update. I don't really need to bug them with emails. They appreciate it because old school guys, they got lots of time to talk to you in person, right? So the young guys should seek those old guys out and realize that if you got gray hair and if you're doing estimating, there's a pretty good chance that you're managing the risk for that owner properly.
Yeah.
And a lot of time the owners were estimators. It's very rare that an owner came up and became from operations into ownership. Different paths to the top, but it's worth going to the top. It's worth spending the time. So
fantastic. So let's switch it up a bit. So I do want to go into footprint engineering. So maybe just start off with telling us a little bit more about the company.
So footprint engineering was a result of result of that shotgun that happened 4 years ago. It's always, you got to ask yourself in life, is it good or bad? A lot of times things change and you judge it and you think this is terrible, but because I had a pretty big company, like when I left, I had 300 employees, and we did projects all over Canada, every province. I've never done projects in the States, but I have a reputation for being innovative, and I used to do industry magazine articles, try to get the cover page, go to those trade shows. I've been to every U.S. city and every Canadian city, of course, but the Americans, they travel around, the American Drill Shaft Contracting Association. I mean, I had people that I still know that I would meet, and they'd say, "Oh, geez, you kid you about getting gray hair," but they always knew that I would ask those questions, and tell me what the rig does. So once you understood how to buy equipment, then you could innovate the actual foundation. It was a tremendous advantage. I got to say, there's few people who know how to get low costs on a job. That I connect all those dots. Like, for instance, if you look at value engineering, it's a measurable verb, an actionable verb, measurable noun. You got to break it into 2 words. So mine is lower CO2. I said, this is the issue of our times. We can do carbon capture, we can do carbon tax, but how about let's not generate it at the source? And then you get the cost and schedule savings. So that was a form of advantage in 22 years in the final business HCM group. And today, now I'm loving life because I have 8 people. So, it's great.
That's awesome. And I want to take a step back on this, and I want to go further into the CO2 problem and lowering it. And I don't want to assume that our viewers are going to understand that exactly what it means and exactly the problem that you're working on solving. So maybe start there.
Well, I believe we should stop the additions. So in other words, when you get CO2, in the particulate form, we're dealing with warming, we're dealing with Arctic ice melting, methane release. And I went down the road in the last 10 years of educating myself. I read a lot of books. I read all the business books when I did my MBA. I try to do self-help stuff. And after a while, you just say to yourself, what's important? Money's not important. It's using your expertise to make a difference, whether someone's life, your kids, all that stuff, right? So I'd like to make a difference. And I think that'll be my legacy. These patents are unbelievable. I can't believe, sometimes I wonder where I came up with them. But I certainly have lots of time to talk about them. And I'm going to say, it might get a bit technical here, but knowing that most of your audience is American, I'll try and use, imperial, not metric. In Canada, we had to know both. But when Americans came up and they owned the development, they really wanted to use feet and inches and all that stuff. So I'm a little bit good with that. rather than mention kilograms and meters. So let's say you take it from here, like which.
Let's start with waterproof concrete. So tell us a little bit more about that one.
Well, that could be the game changer.
Yeah.
Like I have.
Oh, and actually, before we do that, how many patents? Just to give the audience, and we will have time to go through multiple of them that I found interesting. But how many patents have you worked on? Or I mean, it's one of the things that really struck me as we were kind of doing the research for this interview.
Well, when I did the business for 22 years, I had a lot of innovation there, but you can't own it when you get shotgunned out of it. Yeah. So then I really studied rehabilitation first. And I figured, okay, what's the best way to rehabilitate things? And I learned that, if you put colloidal silica on the existing matrix, if you don't overdo it, if you use German mortars, if you use the best layers, I could get maybe 40 years out of a rehab job. Yeah. And then I thought, well, really the problem is, why is this bridge falling apart? Why is this becoming such a society issue that we have to keep rebuilding structures and, tearing stuff down? We have stone buildings. As a matter of fact, I'm in a building right now that's from 1880. Wow. I bought this building and I'm just freshening it up, but the solid thing, stone foundation. You look at that and you say, well, we're tearing our buildings down to build high rises of tremendous footprint. And I guess that's all about, office space and people want to be in condos. But I get all that. But when you're going to do that and you're going to dig a 5-story underground parking garage, maybe you can do that in half the time. I came up with a system to solve what's called the Toronto bathtub. And it's half the schedule, a third the concrete and a third the rebar. And really, I might sell it or I'll license it. I don't know. I might give it away. But the idea is to get it used. So in the last 2 years, I've come up with 12 patents. Wow. And I've got, I think, 7 approved. So it goes patent pending. Trudeau had a program, Green Innovation Program. He promised you review in 4 months. And then the patent highway, we call it. They got very good patent agent, Neil Tannenbaum, very experienced guy, very good trademark person. So I trademarked this stuff. And for instance, Earth Honoring Systems is a trademark I own in North America. And I got that by listening to a guy called Paul Ehrlicher, who's a famous Harvard guy who said, we should come up with systems that are friendly to the earth. Yeah. And so I trademarked it the next day. So anyway, that's the framework here. I'm into Earth Honoring Systems and I have some amazing patents. So we don't have time to talk about them all.
Yeah, let's start with the waterproof concrete. I just wanted the audience to get a feel for just the framework of what you're working on, because it's big, but let's definitely cover a couple of them. So let's start with the waterproof concrete, please.
Typically, the standard of waterproof concrete by large companies such as Crichton and Zypex is they're billion-dollar sales in the world. And they promise a crack filling concept. So basically the crystals gel up in the leaky crack. If it's over 0.1 millimeters, you're out of luck. So they're putting rebar in because it is always over 0.1 millimeters because nobody focuses on the mix. So with the rehab thing, I moved into the new concrete challenge and I came up with a mix 1 where I use admixture that's within the concrete. And I use mag oxide, which Sika owns pretty well, corner the market on. And then basically the right thing, I use Aquagel. Aquagel out of Ohio, American companies, amazing product. They're the market leader in mining. 10% of their business is in. But Aquagel is a great product because it's a rheology modifier. And when you put it in concrete, you can hold slump for 3 hours. So that became mix 1. Nobody adds water, a little bit of QA. That itself will never crack. Now, people say, hey, don't say it'll never crack. It's a liability. Well, I'm given a 5-year warranty on that, and I don't even do the job. All I do is charge a little bit of a fee to have enough I hire the best waterproofing companies if that comes up, but I haven't seen it crack. And I've done a lot of work. I'm a shotcrete specialist. I brought shotcrete to Toronto in HCM, and there's a lot of final walls done with shotcrete, without forming. So then you got to say, well, let's not have that crack. And what about that water stop? And so it's attention to detail. And this particular system in Toronto, I developed something called a feather edge. I do 2 5-inch layers. I run it by the soldier pile. and I completely entomb a P4 or P5. There's no anchor leaks. And you actually end up getting out of there in half the schedule. And you don't do the raft slabs. You know, these raft slabs are 4 or 5 feet thick. They're taking dirt out of Toronto. It's $100 a cubic meter to get it out of the city. The savings are unreal. I can save a guy in a P4 right now $6 million.
Wow.
So, hey, what do I charge? I'm going to say, well, 4%, and I'll give you a 5-year warranty. But I changed the nature of the standards. Engineers can override specs, and I'm not afraid to do it. So let's say if you have 2 quilts, you think about 2 quilts, and you stagger them, and you have the joint go from 5-inch layers, so you go from 5 to 10 inches. I call that a feather edge. And so you put a wood float finish on that. You stagger those 2 quilts. You use my concrete design mix 1, and you will not get a crack on 100,000 square feet or 40,000 square feet. And if you don't get a crack, you don't need crystalline. That's the wrong idea. Those billion-dollar companies are going to go by the wayside. That's mix 1. Now mix 2. Ask me about that. I've created, I think, 200-year concrete. And by I'm
200-year concrete. That's a big deal.
200-year concrete. We're going to get rid of rehab in this society.
Yeah, that's
and this is great that you're giving me an opportunity to talk about it. But basically, I use the Aquagel. I can take the same amount of cement that a 3,000 psi mix would normally be driven with. The weight of water. I replace some weight of water with Aquagel slurry. I replace some weight of water with E5 colloidal silica. Great guy, Joe Shutterby, 3rd generation finisher. Again, I listen to that guy. I can still learn off that finisher. So then I use colloidal graphene, weight of water. Colloidal means suspended in water. These technologies that are nano-based are very safe when they're handled properly. Yeah. And I use colloidal titanium. So let's say I have that mix, and I standard aggregate, standard gravel, shotcrete, it's got smaller gravel. That's the only difference. I can do a 4,000 psi result from a 3,000 psi mix, and I can produce it at the cost of the 3,000 psi mix. So it's in strength enhancement, 1/3 more strength. We're testing it with John Belkovich at Intelligent Concrete in Colorado. Great guy. Ex-Marine. I think he's in the Marines. He's a real character. So John's become a great friend, and that would be typical. People see what I'm doing. They want to do this. They don't want to have it that we rehab concrete. So I call that mix 2, and I'm calling it 200-year concrete because you won't find a crack. And Romans used to do this. You've heard of Roman concrete, eh? Yeah. And that stuff, that was 500 years. But who knows? I can't wait around to test it. But you never know. You never know, right? Maybe I'll figure out how to live longer. So that's a really good set of patents. Those are the last ones. They're filing as we speak. I'm going to go into the U.S. because Trudeau couldn't keep up. He got too many people submitting stuff in 4 months, and it takes 6 months. But my patents are falling like bowling pins. And they're so creative.
What's been the response like from the industry on this concept and just on the concrete in general? Like, what's been the response you've received?
Well, I'm so busy with creating them.
It sounds like it.
that I figure I'm going to stop now. That's it. Somehow 12 seemed like a good number. So I figure, if I can get them all to fall over.
I don't think you're stopping, Martin. I know we haven't known each other that long, but I'm just throwing this out there. Next year, come back on the show. I'm going to be like, Martin, where are you at? You're going to say, well, I was at 12 and I thought it was a good number, but.
Well, let's do it every year. I have to go in the implementation phase. Sure. If we look at the importance of this, absolutely, it's pretty tough to get market penetration. I'm trying to make a deal with Sika. I don't know what they are, 15 billion. And then I can give it to them and they can go worldwide with it. But it'll be mixed too. The price of these colloidals with this nanotechnology. Yeah. Let me tell you, colloidal silica, when you put it into a concrete mix, what happens is it generates CSH gel. So it shuts off the pores. What we want to do, Adam, is we want to make it so you cannot have salts or acid rain affect it. And you can put it next to roads and it won't affect it. Yeah. But the real savings is making engineers realize, the detailed engineers realize, you don't need to control cracks with rebar anymore. Wow. When I look at what a but 1,000 kilograms, let's say 1,000 pounds of cement, is 1,000 pounds of CO2 in manufacture. You know that steel, 1,000 pounds of steel is 7,000 pounds of CO2 in manufacture. I mean, these numbers are huge. In the world, they say we use 100 billion tons per year of Portland cement. So this is a standard cement that everyone's got used to working with. They can do, all these big companies get their infrastructure producing those cements. Companies like Lafarge are all over North America. So those companies, to some extent, they're not really that helpful when they're putting chemicals in that make the company porous, the concrete porous. But if I could deliver them nanotechnology at low pricing, because my suppliers, and I'd love to mention some of these suppliers, but they're basically my friends, and my job is to get them market share. Like if I can get them market share, then they can do the selling. They have to do that. I can't be handling these products anymore. I have to let them. I'll do the testing. I fund the testing, and we're going to produce results. Sika's anxious to see them. Sika's a big elephant. Who knows how long they'll take? But I'm talking to them in Canada. And Canada's a very innovative construction market. I think even the Americans, even though we're 10th the size, they watch what we do. We have a lot of immigrants in Canada. There's a lot of equality. And so, not to say anything against that, there's a lot of great Americans. I have so many great American friends. And so, listen, I just in gratitude today.
It's awesome
to have this interview and to be able to talk about mix too.
I want to get into the next patent, Martin. Okay. So the geothermal patent. So let's get it, because the concrete one, I mean, I'm excited to hear updates on this one, but we have some more I want to get through. So geothermal patent. So tell us a little bit more about that one. Okay, so the acronym, the trademark is FE, FE small e, and then BTU cell. So, instead of plastic loops and drilling down into dry ground and putting grout around it, which in dry ground, you might get a return on energy. They call it COE or COP, coefficient of energy. And so a ground source heat pump might generate a certain amount of cost to run. And we measure performance based on, how many BTUs are you getting out of it? So that might be in dry ground 3. I have created a system that using a double steel liner, which is highly conductive, where the inner liner is steel, closed system water furnace, and between the two liners, what I do is use open shaft drilling techniques, drill rigs that are in every city in the world. And I'll drill down there, let's say 25 feet or 50 feet. I'll go with combinations like 12, 48, 18, 72. These are commercially available millisecond liners. 3/8 is enough. It'll last forever in there once it gets below grade. So then I leak out from the inner pressure. You always have makeup water. It's like a rad, eh? The rad, a radiator with water, you can leak it out and get the air out of it. So I set a valve with that. The inner overflows to the annulus. The annulus is full of water, okay? And then I overflow the water into a slightly over-drilled gravel diameter, and I create literally wet soil around those liners. And I can get a CME in dry ground of 10. So I'm doing that at my farm right now. I'm drilling those holes open. I'm doing a little building. I'm going to put those in there. Now, I talked to John Belkowitz. He's bought a place in New Mexico. And I said, well, where's the water? 200 feet down. Okay, pump the water up with your well. You're going to anyway for your house, right? And then you're not these are closed systems. I mean, you'll overflow a bit of water, maybe 3 gallons an hour, just to wet that outer liner. And it's an unbelievable patent. I predict that within 2 years, I should be able to sell 500 of those, license them out for, I don't know, 10 grand each. Maybe they're definitely going to be charged because it's such a good return, right? And, the key really is to get off grid, to not be dependent on this feed from the road or the gas. Are we always going to have gas? I mean, what a terrible thing that gas thing is, because we're, might be clean gas, but there's a lot of oil furnaces still and whatnot. So we should be doing geothermal everywhere. And they do in Toronto. They'll actually take water from the lake, and they have what's called district energy concepts. So those are good things, and they're wet. But by the time you pump it all around Toronto, we got a big condo boom in Toronto. We have 100 tower cranes right now. And so
they're doing 600-foot loops in the basement down at P4, P5 and low headroom after the guys are out of there. And that you do one hole a week there with a return on energy of 3. Before the guys even start the concrete, I can do 3 of mine with the drill rig before it goes off site in a day, maybe 2 days. And I can do the heat cool in the 25-story condo. That's the calculations I have. Again, I got to test it. But when you test one and you measure the amps properly, like the electrical load properly, it scales, right? Engineering scales. So whether you do 2 or 3 in series or in parallel, these are basically double-lined wells, steel wells that are very suitable to dry ground. And I got to tell you, that could be the best one. So I rate these patents. I'm going to put it on my website, winner 9 out of 10. And then, I hope I get somebody who can answer the phone other than me. But typically my business phone goes to my cell phone. And if you phone me anytime, I'll always call people back within 24 hours. I always felt, as when I was in sales too, and I could talk about that part of my career. And you want to talk about that, how I got into sales? Because when I lost, I don't know, I shouldn't take this far. You asked me more questions, or maybe we're almost
done. I want to get into some more of the patents. So the Fang Earth honoring system. Tell us a little bit more about this one.
Well, Fang Earth honoring systems is almost a frame around all 12. Basically, they're all going to lower CO2. They're all going to satisfy the value engineering definition of lower CO2. Actionable verb, measurable noun. We can measure the amount of CO2 in a project. I came up with a score. I have a trademark for that too. And it's called CETA score, Sustainable Engineering Design Audits. Engineers should be mindful, and they should sit around and do value engineering at the start of every project. And they should say, why is this too thick? How do we reduce costs? It's a 7-day cycle for CVS, Certified Value Engineering Specialists. There's some very good ones in Toronto. Hydro do it. The MTO, like the highways, will do it. But private guys should do it. A lot of times big consultants on infrastructure projects, you know what a P3 is, Adam?
I don't.
We're build, own, operate. So we've gone to this model where they'll tender something out at tremendous risk to contractors, build, own, operate. The European guys are in here now. They're going for these build, own, operate things. But the subway walls in Toronto in the main stations are 4 feet thick. And they say, well, the purpose of that is to deal with nuclear fallout. Well, I'm pretty sure I'm not going there if somebody drops a bomb in Toronto. So that age is over. Let's thin the walls out. Let's use waterproof concrete. Let's get rid of the rebar matrix, because why is it there? It's not there based on the load of the soil. We have very good engineers like Isherwood Associates in Toronto. Now they're very busy and they can pick and choose their work. But why not follow their standard? Why not create value engineering and put them at the table every time? That 7-day cycle will save a developer $5 to $10 million right away. Big engineers have consolidated. One of the problems we have is they've consolidated into this huge engineering companies. And their model is run by the bean counters. Let's get a stock going. Let's do this. And to tell you the truth, they look at the project cost of concrete and rebar, and they say, why would we reduce it? Because we get 8% of those hard costs. It's a big barrier to entry relative to my concepts. But everything I've ever done worked. So I have some credibility here. I've never had a failure in 4,000 design builds. So why can't that work everywhere, Adam? We need more thought leaders. We need more value engineers. And there is a growing number.
It seems to me like it's the natural progression, though. Like as people become more educated about this, even as people outside of the industry become more educated about it, the idea of value engineering, and it's just logical. So it's done in many other businesses, of course. If you can save, cost, and if you can schedule better, like some of the things that you mentioned, like save time, like it seems to me like that would be the progression over time, right?
Well, I think the developers are tuning into this one. And there's developers in Toronto that are on my LinkedIn. And, when I post something like Mix 2, I get 100 views in 24 hours. So then, everyone's saying, well, where have you done it before? And I'm used to that. But, we'll do it once or twice with somebody that's progressive as a developer that wants the $6 million in savings.
Mm-hmm.
and we'll have Isherwood Associates engineer it if they will. I've got a couple other specialized designers, small
Yeah.
boutique firms that like to do detailed design properly.
Mm-hmm.
And so once you do that, when you do my drained vertical shoring system in Toronto, you're draining the water. There is no water pressure. So the typical system, you have to look at the typical system. It's contiguous walls. They're all over North America. The Europeans brought in these Luffer drill rigs, big horsepower rigs. A rig will cost $200 million US, no problem.
Yeah.
And that's fine. They have those rigs. But what I do is I interrupt that wall, and I only do one hole, let's say every 8 feet. But they actually interlock the holes, and they're called secant piling. And it's a grout wall. It's all good in theory. But if you're holding back water pressure when you could drain it, you're already resulting in higher anchor loads. And then what happens is they say that's a bathtub. Okay, down below the footings, we're going to blow up through the footings. Well, in Toronto, the clay extends from 30 feet down. It gets progressively impermeable. There's rock in Toronto. There's clay. Somehow, through regulation of the government, they didn't want to expand treatment plants in Toronto, the Ashbridges Bay situation. It's out in the lake. Well, then let's tell them that they got to hold their water on site. So then hydrogeologists, for the geotechnicals, they don't want to be sued. If you want to know how to control engineering, control the lawyers and try to give engineers the value engineering phase. And once a few engineers see it, everybody cares, Adam. There's a lot of young engineers now that care. They know that the ice is melting in the Arctic. They know that there's three major causes to this problem. Transportation, the methane from beef and all that from agriculture, but 40% is the built environment. And maybe we can save 10% of that in the next 5 years. And maybe we can build a little less. Maybe we could put geothermal in those garages, right? So the combination of patents is very interesting. I'm actually doing some where you can couple them.
And so I would like to round this conversation out, though, just kind of circling back to the overall theme of how, concrete and steel, if done properly, can be less of a burden on our planet overall. So some of the patents that you've done and the idea that they can possibly, give back to lowering the CO2 just problem in general. But then also in terms of the resources that you're saving. So can you talk a little bit more just maybe on how, concrete and steel are hurting our planet and why these patents are so important?
Well, it goes to the total amount of CO2 in manufacture of each one of those. If there's 100 billion tons cement made a year, then there's 100 billion tons of CO2 made from that. That's a direct relationship. If I would say rebar is the real low-hanging fruit. If you look at now crackless concrete, then we don't have to put rebar in. You can see rebar sometimes. Oh, why is that rebar there? Well, we can't have it cracked. Well, now if you can pour plastic for concrete, and if you can save cement in the concrete, I can save 7 times the CO2 effect, and I could probably get rebar in half. Yeah. So that's huge. That's huge. That's a big one. I think we could get the built environment total CO2 problem in half. So that's pretty good contribution. And I could, I'll continue to drive it. I'll continue to do what I can. But, the key for me is I got enough money. What do I really need? What I need is to see this legacy effect and to have young people see it work so that their 40 years, they're going to go from there and improve it even further at them, right? Really, young engineers are great. There's no reason that these kids with masters shouldn't spend time in the field. They think that they should get a promotion right away. Or they think, that they should have this computer technology on their desk. I would say don't take the computer in the field. The guys I work with, they were boots on the ground. We worked with work boots. I have a set right here, and I'm doing work on this old building. So I got a carpenter. We innovate the decks. I came up with a pile that's actually patented. Of all the, the last one is called the FE combination pile. Or combined modulus piles. So you start with gravel in the bottom, not concrete. Then you put a pretty big pipe in, let's say a 16-inch pipe, and you could put holes in that pipe, and you could pour the concrete 6-inch slump which is sort of a wet concrete, through that pipe. But before you put that pipe, you tap that gravel, and you can pack that gravel, which is incompressible. So right away, you're saving a fair bit, and you're getting the movement of the base to move with the shaft, because typically engineers will either give you shaft friction or end bearing. This is a tremendous waste. You know, when in Toronto, when we tested the rock in the 80s, we couldn't fail the rock at 150 tons a square foot. So 75 tons a square foot, there's your design. And we used to drill into the rock 3 feet. Well, now all of a sudden, we don't want any risk, but there was no risk in the 80s. We built lots of big buildings then. So then they say, okay, let's just go 50 tons a square feet. And we'd like you to drill 3 meters or 10 feet into that rock.
Yeah.
And that makes a huge difference, because you're filling that hole up with concrete, right? And then you say, well, let's put some more rebar in. And because really the total cost there, I'm used to getting 8% of that, right? So you get this in infrastructure. The governments should be listening. I mean, the developers will listen. They're pretty wise, and I'm monetizing things in a smart way. So I'm saying that I'm not giving it to a contractor to take all the money. I'm saying to the developer, you can save this schedule, you can save this concrete, you can save this rebar, and that'll fall out to them at $6 or $8 million for a P4. Now think about the heat cool combined with that. Then all of a sudden, everybody's happy, and people are going to want to buy that condo. Well, then there's more demand, right? And if you do it on every floor of the condo, the developer who picks this up is going to be really wise. And instead of spending $1 billion on the next subway, maybe spend $500 million. Do the walls properly. Get somebody in the value engineering phase to say, we did it over here, let's do it over there. And take the 1 week. What they do, Adam, is they take 1 week. The CVS picks people. He brings them in, and they all make $300 an hour. No problem. But there is a lot of people who care. There's a lot of gray hair around that table. And they say, well, in the 80s, we did it this way. And they'll say that. And so what happened? We ended up with too many billionaires. I think the U.S. has 5,200 billionaires. When John Lennon was alive, he was a big shot at 100 million, right?
Yeah.
So this idea of billionaires, like, what's a guy going to do with 1,000 million? And it's sort of a disease thing, eh? But there's not to say there's not a lot of good people. They do charity and they'll do things like this. Toronto was built by the tradesmen and their families now. You'll see things that their fathers wouldn't have liked. But nonetheless, we don't want to go backwards anymore. Let's go forward, and let's do value engineering, and let's do it with the best value engineers, and let's teach our young people that that's a viable career. Right? Because why not? Right? They're going to learn so much when they go around that table. It isn't all engineers around that table. Like, you would have a formwork guy there.
Yeah.
And maybe that guy's got too much work. Well, he gets pretty innovative when he has too much work, right? so if he just gives up. He knows that when the wall went to 18 inches instead of 12, he just throws his hands up. He says, well, it used to be a lot less in the 80s. Well, let's look at what we did in the 80s.
Yeah.
Let's do a survey of the garages and realize there's nothing wrong with that concrete. And we got better concrete now. So a little bit of common sense, sort of a steering committee, maybe. I'd be interested to participate, but I really want to get my 12 patents to the point where they're properly described on a website, and then I'll just sort of let people use them for very low cost. It's going to result in a ton of cost and schedule saved, and governments can afford this subway or this train station, and we don't need to have 2-foot thick walls in a treatment plant.
Yeah.
It falls out when you have concrete, when you have rebar that's crack control.
Yeah.
Then you can get rid of half of it right away. Because on mix 2, you do not need crack control rebar. So all of a sudden, instead of every 4 inches, a 20 M bar, we'll go back to a 15 M bar is 3/4, a 20 M bars, let's say 25 M 1 inch. So you can get rid of the bar size, you can get rid of the bar spacing, you can get rid of the layers. The biggest thing I'm excited about is reducing rebar. And it takes a lot of time to tie the rebar, Adam. You've seen people tying rebar, and it takes 2 weeks to tie a wall, or a week. Somebody's pressuring them to get behind schedule. Like, contractors would be wise to do more work and contribute to the whole thing we're talking about here. Let's just do a little more work. Let the most efficient guys survive, and don't let people get charged because they miss the schedule.
And so as you take these patents to market, and as you kind of push the envelope on this, like and just share maybe part of your go-to-market strategy for this. Like, are you accepting investors? Are you like how you plan to scale this and kind of move the thing forward?
Well, typically patents get licensed, and I think there has to be a quality assurance perspective to who gets licensed. So if you're going to save $5 million, you can sure as heck have a guy on the site watching everything. So in other words, it should be supervised and daily reports should be done. And that's a low cost. And that also reinforces large engineers who feel there's risk, because they get a little bit of money from that engineer being on site, right? We can teach our young people to be inspectors. John Belkovich does a very good course on how to read a batch ticket out of a truck. Unless you've taken a truck and watched them put water in secretly on you, and been on site where you had to chase the guy who's trying to put water in so it's easier to pour. With Aquagel, these slumps hold for 3 hours. So therefore, once we get used to this, Aquagel will be in every load. There's a guy named Paul Finley, companies in Ohio. I think they sold for 180 million because of their mining position, but they're getting into concrete, and I tell them this is the time. I'm gonna recommend that they're in every cubic meter, because we can add water. You understand probably even intuitively about adding water. It's going to crack it. You lose control of your mix quality. So those things should be more my bar. If a guy's got a QA program, I would probably give him free use for a year. If he can add to the database of information from the lab testing, because when you do work on a structure, you're always taking cylinders on every pour. Cylinders are standard things. You take a slump test, you take cylinders, and then you break some of those cylinders in the lab. So if you break those cylinders in the lab and you're consistently getting over strength, engineers will believe, I can reduce the amount of cement in that. And I'm getting impermeability, and I do believe this building will last 100 years longer. And that, it's proof. Proof is in pudding, right? Yeah. If the pudding tastes good, it's a cake mix. So if the cake mix works consistently, and if engineers adopt a quality control approach, that's my vision. I'm not looking to take risk for anybody. I think we got a lower risk, and I think we're going to, because when you're mindful in detailed design, you catch things that the guy didn't catch, right? Like I talked to a guy the other day, and he was in my old company, and he was talking about the difference between an elevation and a section. And sometimes young engineers will rush that out. The section will be different than the elevation. You could end up drilling a whole wall of secant piles 1 meter too deep. So that's waste from a lack of QA. A lack of QA coming out of a design office of an experienced person. Large engineers who get it right, they typically have guys looking at those drawings before the field actions them. But it's hard for the engineer to review everything, when someone else is drawing it and people are using technicians. It's a very busy world. So maybe we just build a little less too. I mean, maybe we have enough building. I don't know. I don't know. Like I don't think the perspective here is to add more people. But certainly, Adam, we're doing our part.
Awesome.
And that's the message, I guess, for today. And I really appreciate the opportunity to talk about my mission.
Yeah. Well, Martin, I just have to say, it's been a lot of fun interviewing you and learning more about your mission, the industry in general, and really how innovative ideas can really make a difference. I mean, the amount of CO2 that you're talking about reducing in terms of like going forward, I mean, it's astronomical. Those are huge amounts, and these are things that are actionable. So it's not this pipe dream that can't be obtained. Like, it's actionable, and you have proof. That being said, if somebody's listening to this and they want to learn more about footprint engineering or follow your journey, I mean, what's the best way for them to do that?
Well, as a matter of fact, I am going to sell 20% of the company. And I don't really look for a big win on that. What I'm trying to do is get engineers involved with 40 years experience and maybe, you know, a very low entry price. And then I have these things called associate partners, and I have about 1,000 bench years on that thing. And I plan on adding 1,000 bench years a year to people who know people. You know, one of the things, one quick patent, if I got another 2 minutes, is I have an underground culvert repair patent that's certified and modeled to 75 years. And I have basaltic rebar. You know how you have basaltic rebar? You know, when you're a kid, you used to do skipping rope. So I came up with a patent that's like a double Dutch skipping rope. And basically I can wrap that annulus. And if I put basaltic bar in, it's twice the stiffness of steel. And I can get the model. And basically I can do a 75-year culvert repair. I just got that patent 2 days ago. So that fell from patent pending to patent. And I combine it with what's called the FE spiral, which is basaltic rebar. So we should be looking at basaltic rebar. You can get it from Russia. You can get it from different places. I talked to a guy the other day in New Jersey. You know, I have a very good engineer friend, David Lawn from Meta Design. He's got that going. And that's a real game changer too, because if you get the cover wrong, like, you know what I mean? If you're next to the earth, that basaltic rebar, it ain't going to rust. And if you don't rust, you don't get the spalling of the concrete. You start to get the engineer confident. That's a great idea. And then they'll use it once. You know, right now we're looking at doing the 407. There's 900 culverts. And normally you would repair a culvert and you'd rip up the road. Well, you can't do that to the pay road. So basically in place, I met the budget of what the large contractor wanted. I halved the schedule and I gave him a 75-year life, which the owner also wanted. So that's a $350 million job for that guy.
Amazing.
And, I mean, why wouldn't he get it? I mean, there's nobody else is going to get it. And I have the HDPE, high density polyethylene plastic. Matter of fact, I'm going to go pay for the dies in an hour. I'm going to go down an hour from here and I got to put 20 grand so the guy will finish the dies. So I have, okay, this is great. I have 6, 9 and 12 inch HDPE plank, 313 wall. That stuff will never get wore out. And I have it like click flooring, slide it in and out and put the FE spiral around it. Bang, 75 years. They said that they wanted that done for 3,500 a linear meter. Well, by my costs, and I know how to estimate civil work, I can do 100 feet finished a day. And that would be a controllable crew. And it would be, I figured that the contractor could make 100 million on it, on 300 million worth of work. So, you know, I'll charge for the planks. And we'll just tell the guy, hey, run more planks for this guy. And then we'll look at it as a continuous improvement thing. Where if you had this detail or that detail, but mostly when I do these patents, they're in ranges and I got it nailed because of my experience. In other words, they're all going to work. They're all going to be constructible, actionable, like you say. It's a great word, actionable. We got to action this stuff now. But listen, I'm willing to take investors. I'm willing to do footprint engineering by state and say you can have all 12. If you guys are value engineers and you have QA, I mean, it would be a wonderful thing to get leaders and leverage it by resources of people. You know, people need jobs. I think that's true, right? And so let's give humans a chance, right?
Awesome. So how do people follow up? To connect?
Well, they can call your cell. No, I'm only kidding. I got to tell you, you know, they can call me 519-240-6334. If they want to put in 50 or 100 grand, you know, I'll give them quarter
This
percent.
is awesome. And I'll let you save that one for the phone calls you'll get. So I'll definitely let you save that one so you can have those discussions one-on-one. But Martin, really, it just has been a pleasure having you on the show and learning more about everything that you're doing. And to the audience that's watching, as always, thank you for tuning in. If this is your first time with us, we're all about bringing on mission-based entrepreneurs, executives, and experts at Mission Matters, and really having them share why they do what they do, like what gets them up in the morning, what gets them passionate, that passion going, and them all fired up. If this is your first time watching, don't forget, hit that subscribe button. We have many more entrepreneurs and executives coming up for you, and we don't want you to miss a thing. And Martin, it really has been a pleasure having you on the show, and I'm excited to continue to watch your journey. It's been fun.
Yeah, footprintengineering.ca. And I'll probably say it's Martin H at footprintengineering.ca. But if you go on our website, it's all there. I'm going to put all the details there. you know, it's a lot of work to do websites, but nonetheless, it seems like the world's doing it, right? So,
Awesome.
and you can reach that. .ca is a Canadian thing. Anyway,
All right.
thanks
Thank
a
you,
lot.
Martin.
Okay, take care, bud.